Alright, ladies and gentlemen, in this video I'm going to be going over arithmetic operators and conversion types. So let's get started. Alright, so I wrote out most of the arithmetic operators because of the fact that it just saves a lot of time. And if you guys are, older than 6, you probably already seen most of these types. So just to save some time, my time and your time, I just wrote it out and we'll just go through it step by step. So addition, right? So we already see it from the get-go. I already created some variables. I grouped them up, and I have some with different types. This is going to be important as I start to go through it. But you should see, A, B, C, D, and that's holding different types and different amounts. So the first thing we'll see is addition. We're seeing A plus B. A is holding 4, B is holding 5. A plus B is 9. So because 4 plus 5 is 9. Now, one important thing about Golang, and that's the first thing that I actually really want to go over, is the fact that Golang is very serious about the types that you use for arithmetic operators. So we see that A plus B, or A and B, are both integers, but it's very serious if we try to use another type. So say for instance we try to do C, or A plus, let's do D. You can see D is a 6, right? So 6 is technically an integer, right? It's just 6, but it is being held as a float of 32 bits. Now Golang sees that and it's like, wait, hold up, this is a mismatch. You cannot do that. It's gonna get mad because we want to make sure that we're using the same types whenever we're doing any type of math. Now you're probably wondering why. Like, can't Golang see that it's a 6 and A is holding 4, so that's a 10 is still an integer, right? The reason why it does that is because, first of all, Golang, yes, it sees as int, but it wants to make sure that you're using the proper types because it doesn't want to make sure it returns the wrong, amount. So technically, this float is technically a decimal, right? Say for instance, D changes in the future to like 6.5 or 6.6, and you try to do this addition with 4. Now, what is it going to be? Is it going to be an int or is it going to be a float? Does it compress it to int or does it leave it as a decimal? See, these are the type of things that can kind of, mess around with how, Golang interprets it. So why even bother doing all of that when you can just, put it as a type that you're already committed as? So like, just make sure that the types are either an int or make sure, they're both a float. That kind of leaves out the confusion, because you already know that this type is going to be an int and this type is going to be a float, not either or. So we don't have to worry about it breaking or compressing it into a number that you don't want, because remember, it's all about precision. And int doesn't have 0.5554, but a float does. And based on whatever application you have, you want to make sure that either you have all the precision or you don't. But Golang doesn't want to make that assumption for you. So just keep them both matched. Or we can use conversion. We can go and manually put if we want it to be an int or a float, even after the fact that we created it as a float. So say for instance we have D, right? We initially had it as a float, but say for instance we manually want to put it or convert it into an int. Golang has no problem of you doing that, but you have to do that yourself, not Golang, right? So what we can do is we can go in and convert D into an int. So all you got to use is the type and then open up parentheses and put the variable that you want to convert inside. And now Golang is, okay with it. A plus the conversion of this float type into an int is okay. Now, there is still a problem with this. Say for instance, this was like a 6.6, right? This is not good because if we're converting this 6.6 into an int, it's going to cut this off. It's not going to be 6.6 anymore. It's going to be 6 because we're turning it into an int. So you have to be okay with that. If we're doing the conversion, we 100% know that we don't mind cutting off some of the precision or all of the precision into that int number. So we have to manually know that we're okay with that. Or we can also make this a float, if anything. So let's remove this conversion of int. All we got to do is put the type that we're trying to convert to. So in this case, we want to convert it to a float 32. And put that conversion around A, and this is okay too. So Golang sees that both of these are floats. we're using the colon equal assignment. That lets Golang interpret what it's going to be, and if we hover over answer, we can see that it's going to be a type of float 32. So this is what you have to think about when you're doing some arithmetic, making sure that they both match, or if you want to actually convert it and you don't mind losing some of the precision, or if you actually do want to keep the precision, you can turn the other value into the proper type. So let's put that back to where it was. So addition in Golang is a plus sign. So we get to do a plus b, and that's going to be 9. And we can print this out. I'm going to print it out all at once at the end. That is addition in Golang, and really in any language, really, it's just a plus sign. Then there's subtraction, and just like in pre-K or kindergarten, it's just a minus. And as you can see, the same rules apply. We're using the same type for both C and D. They're both float 32. But say for instance, we even Golang gets mad even if you try to do, let's make it a Z, and let's do float 64. And then we're gonna make that equal to 5.5. And we're gonna do C minus Z. It still gets mad. They're both floats, right? So it should allow us to do it, but no. Float of 32 bits is different from float from 64 bits. 64 bits is substantially bigger. So just to make sure that the precision is right, is gonna say that it's a wrong type, it's a mismatch. Because say for instance, like I said, it's trying to interpret it. Is it gonna be, do you want a float of 32 bits or do you want it of 64 bits? If we do 32 bits, then you're gonna lose some of the precision. But if you do 64 bits, then maybe you're doing way more than you want when it comes to space. So to make sure, we can just convert either or to the proper type. So we can convert this to float 64 if we really want to, or we can convert Z into a float 32. That is just something that you have to keep in mind. Even though we can assume that they're both floats, you still have to think about, how much, because that's when it comes to precision. Is it going to be 64 bits or is it going to be 32 bits? So let's put this back to what it was. And that is subtraction. C minus D. We see that C is 20.5. We see that D is 6. Because these are floats, we should expect to see 14.5. Then now we have division, right? It's just a forward slash. We do C divided by D, a forward slash in between. And we see that C is holding 20.5, D is holding 6. It's going to be a decimal. And because we know it's going to be a decimal, it is smart to keep it in a float, which it is. It's a float 32 bits. Now, if it's a bigger number, you may need a float of 64 bits. That is something that you have to keep in mind when you're programming. Now, another one is modulus. You either may or may not know what modulus is based on how long you've been coding or if you ever used it before. But modulus is just that it's going to return the remainder of the two numbers. So let's think about this. So we have B. B is 5 and A is 4. Now, how many times can A go into B? A can go into B, one time, right? So if you do 5 minus 4, there's going to be a remainder of 1. So that's what modulus is going to return. It's going to return the remainder because 4 can only go into 5 once. There's still going to be a remainder after you put 4 into 5. So that is what it can. So modulus just returns the remainder of between the two numbers. So A is 4, 5 is B, and the remainder between the two will be 1. So that will be returned. So if we were to do, let's use another number. If we were to use 15 and 5 can go into 15 3 times. There would not be a remainder because if we do 15 times 3, it's going to be 15. 15 minus 15 is 0. There is no remainder. So if you ever need a remainder, or if you ever need a check for remainder, it's perfect. And I know modulus is used a lot when it comes to checking if a number is even or odd. You know that if a number is even, then that number will go into that number evenly, if that makes sense, so that there will be no remainder. So say for instance, that 4 is even because 2 can go into 4 2 times. There will be no remainder. But if you have 5, you know that 5 is odd because 2 can only go into 5 twice. So there'll be a remainder of 1. 5 is an odd number. So to signify that you want to use modulus, you just use this, I like to call it %. but yeah, it's just a percent sign. Like, and then you would signify that you want to find the modulus between one variable or one number, whatever you choose, with another number. So that is modulus in Golang. Then there is the last one that I want to show, which is multiply. Multiply is just asterisks. Some people, are used to seeing it like a X. So like they probably teach you in school like X, but in Golang it is an asterisk, and it's just multiply. So we have A and B. So 4 times 5 is 20. So we should expect to see 20. And this is also important. If you want precision, if you want decimal, then you use a float. Since this is int, we should just expect to see an int. So 4 times 5 is 20. That 20.0, it's 20. So that's what you really have to pay attention with a language like this. Precision. What exactly do you want? Do you want a decimal? Do you want it just an int? Do you want a small int? Do you want just like an int of 16 bits? Do you want an int of 32 bits? I try to keep a little bit of space just in case it does go over, because you don't want any overflow issues. It will crash your application or it will break. So try to keep that in mind of how much space you need or of what type that you need. And if you do want to manually convert it, if you do convert, watch out for compression, because if you really do care about precision, you compressing that number from a float to an int will cause an issue, because it's not going to be 14.5678. It's just going to be 14. And you're going to be wondering why the math is off. It's because you compressed it. You should have made both types floats. And if you know it's going to be a big decimal, you need a lot of precision, use a float 64, not a float of 32 bits. So keep that in mind. Hope you guys enjoyed that. Hope you understood about conversions is whatever type you need. So if you need int to turn to a float, then you just pick the type, you open up a parentheses, put that variable or that number in between, and you'll convert that number. And it's getting mad here because it's mismatching, but we can just do floats for both if needed, and it should make it happy again. So whatever type you need, you just place this here, open up a parentheses, put the value inside of the parentheses, and it should convert that value. So hope you guys enjoyed the video, and let me actually run this so you guys can see. So go run, and okay, so the linter, I'm not using a couple of these, so let me just remove them. Let me clear that out again and run it. And you can see addition is 9 because A plus B is 4 plus 5. Subtraction, we see that 20.5 minus 6 is 14.5. And look at the precision right here, right? It's 3.416667 for the division. C divided by D, 20.5 divided by 6. And then we have modulus, like I said, 4 can only go into 5. 4 can only go into 5 one time, so there's going to be a remainder of 1. And then the multiplication is, A times B, which is 4 times 5, which is going to be 20. So, thank you guys for watching. Hope that was useful. If you have any questions, leave it in the comment section. And leave a like if that was helpful. Thank you.